what you're looking at here is the small section of E core, which I have cut the center out of and changed it into a C core. So that's the lid for it right there. So we have an enclosed magnetic loop, and this particular transformer has two primaries which are oppositely wound, and hopefully that will cancel out the magnetic field and it will use very little energy when the secondary is placed on it, which gets wrapped in a circle around the entire transformer. I hope that doesn't look disconcerting, because that's probably what it is, and hopefully the secondary will not reflect in any noticeable way to the primary. This is a geometric solution to an etheric problem. So let's see if it works. Okay, this not at all useful configuration has two primaries, and when wired in this way it consumes 6 amps. If I rotate the series connection on one of these primaries, which I may as well do, and connect the same main voltage, you can hear it responds rather differently and uses only 1 amp. This seems very typical. And this is very well sucked. In the previous configuration, and I need to be careful here because there's about 3 or 4 volts running through it. Not really. So back to 6 amps, and there's almost no attraction force at all. And in both ways, there's almost no output as well. So what I'm going to do is try some thin wire, get a whole lot more turns on there, because as you can see, there's not a whole lot on there, and give that a go, and go from there. You shall not pass. Okay, I've gone ahead and tried this transformer with the new secondary. There's probably something in the vicinity of 100-150 turns on there. I have a suspicion though that's probably not the issue. I imagine it's the primaries, or indeed the entire concept. So I've got the variac going in through 2 isolation step-down transformers. I tried it at about 6 volts. Once again, with the amperage anywhere between 1 amp and 6 amps. In the standard mode, with the primaries running complementary, it was a reasonably dirty sine wave output, and quite a lot of input. Oh, sorry, very little input. And when I reversed the coil, bucking mode, the input power went up a lot, exactly as it did before. Changed the magnetic forces that hold the primary together, hold the core together. And I did mention this didn't work in the least, didn't I? But what is odd, one thing that is notable about this whole thing, is when the cores are in non-complementary mode, when the primary cores are bucking each other, the output on the secondary looks just like noise. I was getting about 2 volts peak to peak of pure noise, just an absolute mess on the scope. And that is pretty much what I might expect. I didn't bother trying to rectify it, but I did put a small load across it, and it doesn't produce much current or much voltage. But it is unusual, given that the core and the transformer isn't that non-conventional. I would have still expected a sine wave, but I didn't get one. I got a lot of high frequency noise. So That's interesting, might be something there. I will explore that. I'm going to try a couple of better primaries and a better secondary. This wire I have is only about 28 gauge, but I do have enough of it. So, but yeah, I don't have anything in between. So I'm going to try that and see if I can learn anything that way. I'll let you know if I do. A few changes. This one is asymmetrical to a large degree rather than a small degree. Thick wire being replaced with thin wire. Those comments refer both to the primaries, and the secondary has a lot more turns on it as well. I've also tried swapping the primaries for the secondaries, different series parallel arrangements. It may be asymmetrical, but it does perform as you would expect, very badly. Not as it's been touted to. Yep, this ain't a free energy winner. Not for me, not yet. More to learn.